Hello students, welcome to Studies on YouTube channel. I'm Rahul sir. Hope you guys are doing well. It's an emergency video I'm making right now. It's 1:20 a.m. right now. I'm not going to use my board and marker pen right now. I'm going to use my copy and pen. Actually, a few minutes back I got one call. They've requested me to make a video on sums from the chapter calorimetry from physics. So I'm going to do so. Hope this video going to help you guys. Okay, the book is Concise Physics-ICSE Part 2 Class 10, Selena Publishers book, and the chapter which I'm going to do right now is calorimetry. Some numbers they have mentioned is that some numbers 7, 8, 9, 10, 11, 12 and 13 they are having some problem. Let's see how can I help them. As you can see the question, number 7, it's written: an electric heater of power 600 watt raises a temperature of 4 kg of a liquid from 10 degrees Celsius to 15 degrees Celsius in 100 seconds. Calculate the heat capacity of 4 kg of liquid and the specific heat capacity of liquid. Now I have already completed solved the sum number 7. Question number 7, according to the question I've put down the statements. So the first one is power of the electric heater P is equals to 600 watt, time is equals to 100 second, heat supplied by heater, I applied the formula Q is equals to P into T. P your power and T represents time. Okay, and according to it, so the answer is 600 into 100. Let me correct this thing. I need to put the bracket. Yep, 600 into 100 joule. I used joule because it's a unit of Q, that is heat. Mass of the liquid after that is M is equals to 4 kg. T is equals to, that means the delta temperature, difference in the temperature 4 kg. Mass of liquid M is equals to 4 kg, and the difference the temperature is 15 degrees Celsius minus 10 degrees Celsius. The result is 5 degrees Celsius. Okay, so next part, the heat capacity of the liquid. Heat capacity of liquid C dash is equals to Q by T. We have already got Q from this part, Q, and from here we are getting T. So the heat capacity is going to be 60,000 by 5 is equals to 12,000 joule per Kelvin. 12,000 joule per Kelvin, which we can write as 10⁻³ joule per Kelvin. Let us proceed with sum number 8. According to sum number 8, it is given 0.5 kg of lemon squash at 30 degrees Celsius is placed in a refrigerator which can remove heat at an average rate of 30 joule per second. How long will it take to cool the lemon squash to 5 degrees Celsius? Specific heat capacity of squash is equals to 4,200 joule per kg per Kelvin. Let us proceed with sum number 8. I've already completed the sum number 8. Okay. According to this question, I put down the statements. Mass of lemon squash is equals to M, which I've written is equals to 0.5 kg. Fall in temperature T is equals to 30 minus 5. The difference in temperature 30 minus 5 is equals to 25 degrees Celsius. I missed it. Okay. Specific heat capacity of squash C is equals to 4,200 joule per kg, which is given. Okay, now let T second be time. We have applied the formula T is equals to MC capital T divided by 30. MCT. M mass, C specific capacity, T difference in the temperature divided by 30. Let me make it clear. Okay, formula for power is Q by T. Now this T represents seconds and this represents the heat energy. Pardon me with my poor handwriting, guys. Okay. Another formula of P we can write. We can break it. We can break Q and we can write MC delta T, that means your temperature, divided by time. Now let us crisscross. We bring T here. So formula is going to be MC delta T divided by P, which is the exact formula we have used here. MC delta T divided by 30 divided by 30. Okay, so T is equals to 1 MC delta T divided by 30, 0.5 into 4200 into 25 divided by 30 equals to 1750 seconds. 1750 seconds, and after that we have converted into minutes by dividing it with 60. I've mentioned everything. Probably I've mentioned, okay, I've missed one thing. That's the average rate. Yep, we are done with the sum. Let us proceed to the next one, sum number 9. Sum number 9, it's written, according to the question, a mass of 200 gram of certain metal at 80 degrees Celsius is immersed in 300 gram of water at 30 degrees Celsius. The final temperature is 33 degrees Celsius. Calculate the specific heat capacity of the metal. Assume that the specific heat capacity of water is 4 joule per gram per Kelvin. Let us start with sum number 9. I've written down the statements. Mass of metal M is equals to 200 gram. Final temperature of mixture theta is equals to 33 degrees Celsius. I've also mentioned a separate part that theta represents final temperature. Okay, temperature of metal T is equals to 83 degrees Celsius. Okay, fall in temperature, it's T minus theta, that is 83 minus 33 degrees Celsius, results to be 50 degrees Celsius. Let me correct it. Okay, heat lost by metal is equals to MC T minus theta, that is 200, M200, already I've mentioned here, M200, C unknown. We need to calculate this one. Difference you have already calculated as 50, so put a 50, so 200 into C into 50 joule. Next part, mass of water M is equals to 300 gram. Specific heat capacity of water is 4.2 joule per gram per Kelvin. Rise in temperature is 33 minus 30 degrees Celsius. So difference is, yes, that is 3 degrees Celsius. Heat gain by water equals to MCL bracket theta minus T, that is 300 into 4.2, difference is 3 into 3 joule. I've written as equation number 2. Let us continue with this thing. Heat lost by metal equals to heat gained by water. Heat lost by metal is equals to heat gained by water. So 10,000 into C, 10,000, yep, we have calculated here, 10,200 into 50 joule, results to be 10,000, and see, this is the thing we need to calculate, and from this side we have already got for here, it will be 900 into 4.2, 900 into 4.2, okay, this 300 multiplied by 3, we got 900 into 4.2. See, we did the cross multiplication, 900 into 4.2 divided by 10,000, and results out to be 0.3 378 joule per gram per Kelvin. Let us proceed with sum number 10 according to the questions given. Okay, 45 gram of water at 50 degrees Celsius in a beaker is cooled. When 50 gram of copper at 18 degrees Celsius is added to it, the contents are stirred till a final constant temperature is reached. Calculate the final temperature. The specific heat capacity of copper is 0.39 joule per gram per Kelvin, and that of water is 4.2 joule per gram per Kelvin. State the assumption used. For this type of sum, obviously we are going to apply the assumption there is no loss of heat. There is no loss of heat. All the heat is being utilized. Heat lost is equals to heat gained. Heat lost by hot water is equals to mass into specific heat capacity, CW, into fall in temperature. It might look like full, it is fall in temperature. So 45 into 42 by 10. I have written 42 by 10. The basic reason behind is that it's the question, it is given in gram, 4.2 joule per gram per Kelvin. In the question it has been mentioned as 4.2 joule per gram per Kelvin. So that is why I have written 42 by 10, replacing the decimal by 10. 42 by 10, then bracket 50 minus T, that's the T is the final temperature, T is the final temperature it's attending. Heat gained by copper is equals to mass into specific capacity of copper into rise in temperature, As you all know that the water was hot and we are adding the copper, so obviously it is going, there will be a fall in temperature in part of water and there will be rise in temperature in part of copper. So according to calculation, 50 mass of copper into 0.39 specific capacity of copper, bracket T minus 18. Okay, so let us continue. Your heat loss is equals to heat gained. I've written 45 into 42 by 10, and here a bracket 50 minus T, and here 50 into 39 divided by 100, bracket T minus 18. I've cancelled 50 by 100, we got 2 here, and here I've cancelled 42 by 10, cancelled it with 2, result is 21, we got 21 here, and 5 here, 5 cancelled, 45, and that is 9. So we are left with 9 into 21, bracket 50 minus T is equals to 39 by 2, bracket T minus 18. Okay, next we did the cross multiplication. 9 into 2, that is 18, into 21, bracket 50 minus T is equals to 39 into T minus 702. We are getting this as 39 is multiplying T, so the result is 39 in T, and then 39 is multiplying 18, so the result is minus 702. Okay, next part, we've taken all the T at one side and the numbers at other side. We have the sum of the numbers 18900 plus 702, the result is 19602, and here 378 plus 39 T is equals to, the result is 417 T is equals to 19602. Okay, next T, we did a cross multiplication. T is equals to 19602 divided by 417 is equals to 47 degrees Celsius. Okay, question number 11. 200 gram of hot water at 80 degrees Celsius is added to 300 gram of cold water at 10 degrees Celsius, neglecting the heat taken by the container. Okay, calculate the final temperature of the mixture of water. specific heat capacity of water is given, equals to 4200 joule per kg per Kelvin. Now let us proceed with sum number 11. Hot water mass is given, that is 200 gram. Specific heat capacity of water we have taken at C. T is equals to 80 degrees Celsius. Cold water, M, mass 300 grams. Specific capacity of water, yeah, we have taken C here also. The size might create problem with small letter and a big letter, the capital letter. Okay. Okay. Let's continue. T is equals to 10 degrees Celsius, small t, 10 degrees Celsius. Difference we have taken as the theta degrees Celsius be the temperature of the mixture. The theta is the temperature of the mixture, but not the difference. So the theta is the temperature of the mixture. Then comes the heat lost by hot water is equals to mc t minus theta. Mc t minus theta. Heat gained by cold water, mc theta minus t. Theta minus t. Next, heat lost, mc t minus theta equals heat gained, that is mc theta minus t. Now we have put the respective values. 200 c bracket 800 minus 80 minus theta is equals to 300 c bracket theta minus 10. We have cancelled, or rather we have divided. We can see here that the main should be that what we should say, that we have divided both sides by 100. So what is remained? What has remained is 2 here, and from here 3. I've multiplied this. 2 into 80, result is 160. 2 into theta, 2 theta. 3 into theta, 3 theta. 3 into 10 minus 30. Okay, so we have taken all the numbers one side and theta on the other side. So results comes out. Result is 160 plus 30. That is 190. 3 theta plus 2 theta is equals to 5 theta, and 5 theta is equals to 190, and theta is equals to 190 by 5 equals to 38 degrees Celsius, our required answer. Sum number 12. Temperature of 600 gram of cold water rises by 15 degrees Celsius when 300 gram of cold water at 50 degrees Celsius is added to it. What was the initial temperature of the cold water? Okay. Solution of sum number 12. Written, let the final temperature of mixture is capital T degrees Celsius. Rise in temperature of cold water is equals to capital T minus small t is equals to 15 degrees Celsius. Let's see with the specific heat capacity. Let's see with the specific heat capacity. Let me correct my handwriting. Okay, specific capacity of water, and the heat lost by hot water is equals to heat gained by cold water. Next, mass into C into fall in temperature is equals to mass into C into rise in temperature. So 300 into C bracket 50 minus capital T is equals to 600 into C capital T minus small t. Okay, we have divided both sides by 100. So what is left with, we're going to get this zeros cancelled. Now 3 is going to come here and divide this, so the things are going to be like this. Okay, and also this C is going to get cancelled because we're talking about water, and obviously both will have the same specific capacity, so better we cancel it before. So what we are left with, that is 50 minus T, and here 2 into T minus T, and here the T minus T, the difference was already given here. Okay, rise in temperature was already given, that is 15 degrees Celsius. T minus T was already given, so it was 50 minus T is equals to 2 into 15. So T is equals to 50 minus 30 is equals to 20, but rise in temperature is equals to T minus initial temperature of cold water. So T is equals to 20 minus 15 equals to 5 degrees Celsius. According to sum number 13, okay, 1 kg of water is contained in a 1.25 kilowatt kettle. Calculate time taken for the temperature of water to rise from 25 degrees Celsius to its boiling point 100 degrees Celsius. Specific heat capacity of water equals to 4.2 joule per gram per Kelvin. Mass m equals to 1 kg. Rise in temperature, I've mentioned with the delta T is equals to 100 minus 25 degrees Celsius, that is 75 degrees Celsius. Your specific heat capacity of water is 4.2 joule per gram per Kelvin, that is 4200 joule per kg per degree Celsius. Okay. Next, power of kettle. Here P is equals to 1.25 kettle equals to 1 kilowatt is equals to 1.250 watt. Let the time taken in second be T. Okay, energy supplied by kettle I've written, that is theta Q is equals to power into time. Yeah, that old formula that we did today. Next, Q equals to, yes, 1250 power into T time into joule. Also we know that Q is equals to M, Q equals to C M delta T or M C delta T, whatever. Let us put the respective values. 4200 into 1 into 75. Yep. And let us continue with the cross multiplication. It's quite similar to sum number 7 that we did today. 4200 into 1 into 75 divided by 1250. So the result is 1315,000 divided by 1250. Result is 252 seconds or 4 minutes 12 seconds. 4 minutes 12 seconds. Thank you, guys, and pardon me with all the technical difficulties we have faced here today. Pardon me for that. I'm going to be much more careful in later videos. Okay, thank you, all the best. If you have any problem regarding any science subject, physics, chemistry, maths, bio, just mention in the comment section your problem, the question number, question, whatever. I'm going to come up with the video with the solutions the very next moment when I'm going to check it. Students, it's you for the priority. Okay, so don't hesitate to come up with your problems. All the best, guys, and the most important thing, don't forget to like, comment or subscribe, like, comment or share, and obviously do subscribe our channel and click that bell icon so that whenever we are coming up with any new videos, any new topic, you get the immediate information about it.